Hello, everyone. Thanks for tuning in to this episode of the Software Plaza podcast. I'm Twain Taylor, editor at Software Plaza, and we bring you talk conversations like this that we're going to have today, week in and week out. We've been doing this for quite a while, so encourage you to go and check out all we've done so far. It's over at our website, softwareplaza.com. It's also on Spotify, YouTube, and the other podcast platforms. With that, let's dive into today's conversation. I have with me William Morgan, who's the CEO and co-founder of Buoyant. That's Buoyant. And the website is buoyant.io if you want to check it out. And they are the creators of the really popular service mesh tool called Linkerd, Linkerd. If you've built anything with Kubernetes, you've probably heard of Linkerd. It's a really, really popular open source service mesh tool. And they did this back when, how long ago was it, William, that you created Linkerd?
Oh my gosh, you really want to know the answer to that? It's going to be a scary number, but next year, early next year, will be Linkerd's 10-year anniversary.
Oh, wow. Celebrations. Yeah, that's pretty early. So we're talking 2016. That's around about the time that Kubernetes itself was
Mhm.
just getting started.
That's right. Yeah, yeah.
Wow.
And the very
Amazing.
first version of Linkerd supported Mesos and Kubernetes and
Mhm.
Docker's, Swarm
Um,
and Consul, and very
mhm.
quickly, the Kubernetes support kind of eclipsed everything.
Yeah, yeah. Did you, when you created it, what was the idea? Was it because Kubernetes wasn't as what it is right now?
Yeah, so
Uh,
the idea,
yeah.
the original idea was not Kubernetes specific at all. In fact, we had come out of
Mhm.
my co-founder Oliver and I had come out of Twitter, and Twitter had just gone through this kind of migration to microservices from a monolithic, Ruby on Rails app. And
Mhm.
at that point, Twitter was running on Mesos and it was running on the JVM and it was using C groups. So you had kind of the beginnings of containerization and certainly of orchestration, but then Kubernetes and Docker containers started, rapidly becoming very popular shortly after we started
Mhm.
Linkerd. The original idea was just, hey, you're going to have all these microservices and we're going to help you mediate the communication between them because we had seen that work
Mhm.
at Twitter. And then once Docker and Kubernetes really started taking off, everyone in the world was doing it. And the details were different, but kind of the big picture and the challenges they had were exactly the things that Linkerd could solve. And so it became very popular very quickly.
Wow. So 2016, you guys start, and then from what we just chatted about, you're saying 2018 was your last funding round, and that was a Series A.
That's right.
And since then, it's just been running on profit, and that's quite
That's right.
amazing because you've got an open source foundation. I mean, you're based off of an open source tool, and you've got a business on top of that.
Yeah.
And you took in some funding, but then you've been profitable. That's quite a story. Tell us a bit about just what's behind that and some of the lessons you learned. I know it's a lot. You can't really name one thing, but tell us what comes top of
Yeah.
your mind when you hear
It's a
this.
lot of lessons, a lot of lessons learned the hard way. I
Yeah.
think, the biggest one is that in this ecosystem, in the Kubernetes ecosystem or the cloud native ecosystem, everyone wants everything to be open source. And usually what they mean by open source is they want it to be free. And the way that
Mm-hmm.
people adopt these projects is they come in, they download it, they get it working, they'll ask for help if they can't get it working. And then once it's working, they leave. Right. So you don't have
Mm-hmm.
these, we call it the open source community, but you don't really have these kind of community dynamics the same way you would have if your project was like a JavaScript library and its audience were
Mm-hmm.
JavaScript developers. Okay, those are people who are used to writing code. If they don't like the way the library works, they'll submit a PR, and like you have this very natural kind of like contribution mechanism. In the CNCF
Mm-hmm.
ecosystem, people are here because they're trying to get their job done. They want your
Mm-hmm.
tool to work and then they want to move on with their lives. And I think you have to recognize that. You have to recognize that and you have to realize in that world, what they want is a product. They don't really want a project. We talk about open source, but really what they want is a product that works. And so you have to just be very upfront with them and say, this is the open source thing. and this is the commercial thing, and you need to pay for the commercial thing if you are really, truly relying on
Mm-hmm.
this in production. And a lot of
Mm-hmm.
people
Mm-hmm.
don't want to have that conversation and they walk away, and that's fine. Like you just have to get to the point where you have customers and not open source adoption. We made a big mistake. We chased open source adoption for far, far too long. All we cared about was who's using,
Mm-hmm.
more people, more, give you everything for
Yeah.
free. And then we had to
Yeah.
do a pretty strong correction, and it
Mm-hmm.
wasn't that long ago. It was really February of last year where we
Mm-hmm.
changed the way we didn't change the license because you see a lot of companies change the license. We said we're going to change the way that stable releases are created, and we're not going to make open source stable releases anymore. If you want something called stable, then you got to pay for it. And it's big, a lot of drama. I got yelled at on the internet
Mm-hmm.
for a long time, but at the end of the
Mm-hmm.
day, I was like, I have to pay the maintainers, right? Like there's
Yeah.
no volunteer maintainer here in this
Mm-hmm.
world. This work is hard. It's really, really hard. And so you got to pay someone to do it. If you're going to pay, where is that money coming from?
Mm-hmm.
Is it coming from VCs? Well, that lasts, a certain amount of time. Is it coming
Mm-hmm.
from donations? Well, it's definitely not going to work. It has to come from customers. So you're almost forced into this world where if you truly want a sustainable, long-term open source project in the CNCF, you have to charge money for it. You have to. There's
Mm-hmm.
no alternative. So
Wow.
that was the big lesson we had to learn. And I think if we had learned that earlier on, and if we had been a little more careful about how we had set things up, we would have had an easier time of it. Everything worked out great in the end, right? Now Buoyant's
Mm-hmm.
profitable. Linkerd has all these maintainers. We're paying them. The project gets better every day. So the end result is good,
Mm-hmm.
but we had to suffer a little bit,
Mm-hmm.
along the way.
Yeah, yeah. Wow, interesting story there. What would you say is the split between the maintainers who are non-paid, the community maintainers, were there any at all? Was there a percentage at all, or was it just purely, Buoyant employees who were maintaining it?
I think it's very rare in the Kubernetes ecosystems to truly have volunteer maintainers. So the one
Mm-hmm.
way I see that work is if there's like a plugin system and you have someone who kind of maintains one plugin or something like that. But for anything that's core to the project, just the maintenance of keeping up with Kubernetes itself is incredibly difficult. It's
Mm-hmm.
hard
Mm-hmm.
work, it's unpaid. And so I think like most projects in this ecosystem, Kubernetes itself is a little different, right? That's like a prestige project. But for the vast majority of other
Mm-hmm.
projects in this ecosystem, you'll see contributions, well-meaning contributions. Sometimes someone will do something as part of their job. Oh, we need this feature, and they'll implement it. But
Yeah.
usually you have to do a lot of work to get that code to the point where it's ready
Mm-hmm.
for introduction to this complicated distributed system that you're building. And then
Right.
they might disappear and now you're left maintaining it and you're like, well, okay, I didn't really want that feature in the first place. So it really is, it's difficult, and it's very different, I think, from the model that a lot of people have in their head with open source, where it's this, and
Yeah.
this is a model that I grew up with Linux in the 90s. It's this collective effort. It's nights and weekends. There's like this ethical kind of component to it. We're going to take down Microsoft. We spelled
Mm-hmm.
Microsoft with like a dollar sign. We hated Microsoft. We were going to take them down with Linux. And that's kind of like your expectation when you think of open source. But the reality is modern open
Mm-hmm.
source, certainly in the CNCF ecosystem, which is, the part that I understand, and which is different. There's other open source projects that are very, very different. But in this ecosystem, it's a very, very different model. Everyone is here because they're trying to do a job. Everyone is being paid to
Right.
be here. So you have to
Mm-hmm.
recognize that and you have to come to terms with it. And then I think for me, the thing that really kind of radicalized me was for a long time, like I said, we were putting everything we could into open source Linkerd and just making it the most beautiful, amazing project. And then we said, well, we're going to sell support. Okay, like that's the classic thing to do, right? Enterprises are going to need to
Right.
buy support. And we signed up a couple of customers. And then
Mm-hmm.
after a year or two, many of them said, you know what? We've never called you. We've never had to involve you. And so we're not going to pay anymore because we don't actually need support. And
Mm-hmm.
that was terrible because I realized if the product had been bad, right? If Linkerd had
Mm-hmm.
been complicated and had like, all this, these nuances and like it was really hard to operate, then support would be really valuable. But we had made
Mm-hmm.
Linkerd, we had made it simple. We had made it easy to use. Like our whole focus for Linkerd was how do we make this, so that it runs by itself. You shouldn't have to worry about it. And the better we made
Mm-hmm.
Linkerd, the harder it was to make money. And so we had to change it. As soon as I realized that, I was like, we have to do the opposite here because I don't want to make a bad product. I don't want to make something that's crappy just because then I can sell support. I want to make a really good product. So how do we change it? Well, we can't sell support in that world. We have to sell the product itself. And that kind of thought process is what led to the current world where Linkerd is fully open source. It's Apache v2, it's CNCF, but stable releases, if you want something called stable, 2.19.0, 2.19.1, backports, bug fixes, all that stuff, semantic versioning, well, now you got to pay.
Mm-hmm. Yeah, yeah. Yeah, wow. That's quite a lot you packed in there. A lot of it's like a lot of business lessons in there,
Yeah.
and tech, just how to run a business around open source and tech. I wanted to read one of your recent LinkedIn posts, which kind of echoed the same sentiment. Just I think from a couple of weeks ago, you said
Yeah.
the highest impact announcement at KubeCon Atlanta last week had nothing to do with AI. It was the announcement that Ingress Nginx was being deprecated. In one fell swoop, 10,000 Kubernetes SREs learned an urgent and important lesson about open source sustainability. If your critical dependencies aren't funded, don't be shocked when they disappear and you're left on cleanup duty. Tell us a bit more about this. What happened? What made you, what sparked this comment? And tell us a bit more about just, I mean, it kind of echoes what you've already been telling us, but anything else that you want to comment on just hearing this?
Yeah, no, I thought this was a great example of exactly kind of the model that I've been espousing, which is so Ingress Nginx, super popular project. It was in the Kubernetes docs. Like this is a default way that you set up Ingress. Pretty much every Kubernetes cluster needs some way of getting traffic into the cluster. How do you do that? Well, here's this thing. And at some point, so it became hugely popular, wildly popular, but no one was actually maintaining it. Well, there were a couple maintainers, but they were volunteers, and they would issue these calls for help, and they'd be like, "Hey, we've got all these things, like it's hard work, but we need someone to step up," and no one did. And after a couple of years, finally, they decided to, let's not pretend that this is a thriving project anymore. Let's shut it down. And everyone who was on the receiving end of that was shocked, right? And you can read through these Reddit posts where people are like, "What? I only have 4 months to migrate off of Ingress Nginx." Like they're just outraged that this thing is going away. And I think my point was basically like, this is exactly what's going to happen to every project unless there is a way to fund the maintainership, right? There's no more volunteer maintainership in this world. It's too hard. It's thankless. It's like it's annoying. It's not glamorous work, right? It's like it's hard. And so you got to pay people to do it, and everyone else in this ecosystem is being paid to do it. So, I almost feel like this is like we've gotten very good at supply chain analysis. We're like, okay, that we've got all these dependencies in our software, and if a bug happens or someone does something naughty in one of these vulnerabilities, or in one of these dependencies, then that becomes a vulnerability here. So we have to get very sophisticated about how we're tracking supply chain, kind of like stuff, right? We've got SBOMs, and we've got salsa docs and provenance attestations, and like all this technology has been built out. I think there needs to be a similar thing for who's funding these projects. Like, are they thriving? Are they living? Do they have a future or not? Because if they don't, then what happened to Ingress Nginx is going to happen to these other projects. And whoever is using this, if you don't, if you're not aware of like, kind of this aspect of the project, then at some point it's going to be shut down, and you're going to be left with this urgent, unplanned work. And that's just how this ecosystem is going to work. So for me, I'm very happy that we arrived at a solution where I can say to our customers, I can say, "Hey, Linkerd has been here for almost 10 years. I think it's going to be here for another 90 years. We have a system, we have an engine in place that continues to improve Linkerd because the better we make Linkerd, the more money we, our customers will pay us, and the more money we can devote right back into the project. So we have this, we have a system for keeping Linkerd up to date. If you don't have a system like that, then you're at risk. Every one of these projects is at risk.
Wow. And yeah, really, kudos to just you and the whole team at Buoyant for just taking this path and pretty much kind of being trailblazers of sorts. Because for every one success story here with open source, there's hundreds of projects that didn't take off and that had a lot of potential. So it's really quite amazing what you're able to do in this space.
Thanks. Thanks.
Um,
I didn't really
I,
want to be here. I wanted to have the beautiful open source project that people would just throw money at you and like you didn't have to worry about, you know, sales and all this stuff.
yeah, yeah.
I would much rather be there. This is, that's where we were 10 years ago. Now you fast forward to today and this is what I look like and just like I'm worried about the sales pipeline and stuff like that. But that was the only way we could figure out to really make Linkerd a truly sustainable project.
Right, right. Yeah, I want to segue a bit to talking about service mesh and how people think about it itself, and I think it's quite well known about just the comparison Istio versus Linkerd, just two extremes in terms of complexity, simplicity, and how easy it is to work with them and how ready they are just for running production workloads and uh, all those things. But yeah, I just wanted to ask about just people's views on just service mesh and open source, thinking especially about DIY service. I can just run an open source Linkerd or Istio myself.
Mhm,
Why should I
mhm.
be paying for that if there's already mature open source communities around these tools? What would you say to someone who's thinking on those lines of like DIY is the way to go, and maybe they've not yet really, gone all out into service mesh and they're still considering and dipping their toes? What would you say to them?
Yeah, so I think there's two separate decisions. The first is, do I need a service mesh? Yes or no, right? And like I would never encourage you. So I'm an engineer, by background, and the parts of that are still wired deep into my personality. So I would never encourage you to use a service mesh if you didn't need one. Maybe I could convince you to do it
Mhm,
for a year or two, but like eventually you'd be like, oh, what am I doing? And like you'd rip it out. And
mhm,
that's the worst outcome. I would rather you didn't use it than that you did it, for a year and then ripped it out. So do you need one?
mhm,
And there's a whole kind of like technical debate here about, obviously, like with any piece of technology, there's a cost to adding another component to your stack. And then there's some value you're
right,
getting. And like you need to make sure that the value outweighs the cost in like a
mhm,
really clear way. And I think for a
right,
lot of companies, the answer there is yes, but not for all of them. For some of them, the answer is no. The answer is like,
mhm,
it doesn't make sense. You're not doing something that really warrants a service mesh. So that's one question. And then the next question is, do you want to DIY or do you want to buy something? And there,
mhm,
similarly, I think if you're doing this for like a home lab, I think the answer is clear. Like, of course, you're doing DIY.
mhm,
Like, why would you pay a bunch of money? If you're doing this in the
mhm,
context of I'm building a business or I'm building a platform that powers the business, then,
mhm,
you're going to be spending money. You, the company, are going to be
mhm,
spending money no matter what. Either you're spending it on your engineers who are going to do the DIY thing and maintain the service mesh and keep it up to date and all that stuff, or you're going to spend it on a vendor and you're going to say, hey, vendor, you take care of those responsibilities, and our engineers are going to do something else. And I think when you see it through
mhm,
that lens, then it's really a question. It's not a question of are you spending money? It's a question of where are you spending it and what are you having your engineers do? Are they spending
mhm,
time maintaining a service mesh, or are they spending time on stuff that's closer to the business? Most of the time, spending your engineers spending time on stuff that's closer to the business is what you want. But
yeah,
sometimes you truly have these unique needs. Sometimes you truly have the capacity to do stuff,
mhm,
and then a DIY approach makes more sense. But that's how I would
mhm,
I would think about it, right? This is not a purchase where it's like, oh, I'm going to Starbucks and like I need to decide, am I spending
mhm,
$8 on a frappuccino, or do I have a $4 cup of coffee, whatever it is. I don't know. Right. This is
mhm.
like an organization who's going to be spending money no matter what. So that's I think that's really the decision factor is where are you placing those dollars?
Yeah, yeah. Yeah, very interesting that. And I want to also talk just getting a bit into just Linkerd and some of the things it does. And recently I was reading one of your posts on LinkedIn as well about you saying we found a really clever way to cut the AWS bill of several of our customers in a significant way if they're running Kubernetes. We just did this with Imagine Learning
Hmm.
and
Hmm.
cut their network spending by 40%
Yeah.
while increasing overall platform reliability and security. Tell us a bit about just what's behind this, because here is when, as well, like you just mentioned, there's the angle of value and getting more value than what you pay for.
Yeah.
And you're clearly referencing that here. And this, tell us a bit about this story and just how people could think about service mesh and getting value from it from this example.
Yeah, yeah. So this is one of my favorite features because we didn't start out trying to develop it. We didn't say, "Oh, you know what would be good is Linkerd if Linkerd could save you money." But at some point we realized, "Oh my gosh, we have customers who are spending a bunch of money on something that we actually could could reduce for them pretty easily." So,
Mm-hmm.
and uh, if you are basically the situation is if you are in AWS and you're kind of deploying it anywhere, whether it's Kubernetes or not, the way AWS splits their infrastructure out is into different regions, and within each region you have different zones that are called AZs, or availability zones. And the
Yeah.
idea is that um, different regions, right? You're going to have one East Coast, one West Coast. There's going to be high latency, like there's going to be true isolation. But within a single region, you're still going to
Mm-hmm.
want isolation. And so we're going to deploy a bunch of stuff in this zone and this other one. And then if you're deploying something like Kubernetes, of course you want it to live across 3 zones, because if one of those zones goes out, you've got the other 2 zones and the cluster will still work. So kind of the
Mm-hmm.
default, best practice for deploying in something like EKS, which is AWS's managed Kubernetes service,
Yeah.
is to deploy your nodes across 3 zones. Okay, so great.
Mm-hmm.
All is well and good. But then what you don't
Mm-hmm.
realize is that AWS will charge you for traffic in between zones. And
Right.
Kubernetes, of course, is doing its best to distribute the traffic as broadly as possible. So pretty soon you're in
Mm-hmm.
the situation where you've got this cluster and you got a lot of traffic going between the nodes or between the pods, and those pods live on different zones, and Kubernetes is doing its best to like distribute them as evenly as possible and distribute that traffic. And suddenly you have
Mm-hmm.
this bill that's your
Mm-hmm.
cross-zone traffic bill that, if the amount of traffic is low, you don't really care. It's $10,
Mm-hmm.
right? But if the amount of traffic is it's high, suddenly you're paying a lot of money. Suddenly you're paying millions of dollars. Okay, so what can we do in Linkerd land? Well, happily we happen to sit there and we notice all the traffic that's going through here, and we actually can control where individual HTTP requests or gRPC requests go. So we have a feature called Hazel, which is high
Mm-hmm.
availability zonal load balancing, where by default
Okay.
we will keep all your traffic within the same zone. Okay, great. So like if
Mm-hmm.
pod 1 is talking to pod, or service A, sorry, let me put it this way. A pod in service A is talking to service B. It'll just see the pods that are in the same zone. Okay, great. So problem solved, right? Like we've got no more zone traffic. Unfortunately, unfortunately, if one of those zones goes down, then actually you've undone the whole point of having multiple zones, because now there's
Mm-hmm.
no way for the remaining 2 zones to talk to each other. So what
Mm-hmm.
Hazel will do, what the Hazel feature of Linkerd will do, is it'll notice the amount of kind of load that's happening to a service. And as a service gets under stress, whether it's from kind of high traffic coming in or for something else slowing it down, it will gradually allow traffic to happen between zones until the system comes back down to a stable state, and then it'll reduce that traffic. So you're balancing these 2 things. On the one hand, you want cost savings. So like if the system's under normal operation, no traffic between zones. Great, not spending any money. But if the system starts getting stressed, we will allow traffic and between zones. You'll pay a little bit of money, but your system will stay up, and then we'll reduce it back down when things are stable. So that's the magic of that feature. Like I said, we didn't start out to develop that, but we had some customers who were spending ridiculous amounts of money with these cross zone charges, and we were able to basically reduce those down to zero under normal operational circumstances. So they're very happy.
Yeah.
And I'm happy too, because now I have something it's very clear to communicate to someone what the value of this thing is. I don't have to talk about the philosophy of reliability or whatever. I'm like, you're spending $100, we're going to make it so you spend $10.
Yeah. Uh, yeah, it sounds very complex as you describe like what's happening on the back end behind the scenes. And what's it like for someone actually who's turning Hazel the feature on? How simple have you made? Because I know Linkerd, you're
Yeah.
big on just keeping it simple. How easy is that to really to turn on and just to maintain even?
Yeah, it's relatively easy. It's not as easy as it should be. So I think there's like a step two
Hmm.
as we've rolled this out and we've learned from our customers, which is something we're continually doing.
Hmm.
One of the things we're learning is, oh, actually, there's ways we could improve this further. But the way that
Hmm.
we rolled it out is there is a knob that you get to configure, and that knob
Hmm.
it's basically what is the normal amount of load for the system. And sometimes it's
Okay.
very easy to know, and then like it's easy to configure Hazel and everything's fine. Sometimes that number is difficult or it changes over time, and then things get a little more complex. So we make it
Hmm.
as easy as possible. This is one feature where I think we've got some additional work to do. But
Hmm. Hmm.
everyone who's using it's pretty happy with it because they're saving money,
Yeah,
right?
yeah. Amazing. Um, Talking a bit about loads and just traffic patterns and predictability, I want to talk about just AI and segue into kind of one of the key themes of our conversation today, which is just how Linkerd is enabling AI workloads. Uh, I was hoping you could talk to us about how traffic patterns are different with AI workloads from what we've seen in the past and what this means for service mesh and Kubernetes networking.
Yeah, so I, s- I'm a grumpy person by default, so I was hoping we could ignore AI entirely. I was like, oh, maybe we don't need to do anything with AI. I mean, it's like the opposite of what Linkerd is, right? We want Linkerd to be fast. We want it to be predictable. We want it to be lightweight. And like AI is the opposite. It's slow, it's unpredictable, right? So, but once I kind of came to terms with the fact that every one of our customers was starting to deploy these AI workloads, it became pretty clear that actually the problems that they are having, a lot of the same problems are the problems that we've been solving already for HTTP and for gRPC traffic. But now they have them with MCP traffic, or they have them with A2A traffic. They have them with the new types of workloads. And the details are different, of course, and there's things like prompt injection attacks and stuff that like you never had in the past. But
Mhm.
the core requirements around reliability and security, authentication, observability are all the same. So
Mhm.
the way we think about it is the interesting part for us for Linkerd, of course, is the traffic, right? That's our bread and butter. And
Right.
when we look at our customers, obviously they live in the spectrum of like some of them are very early to AI, and then some of them are actually very, very sophisticated and have been running LLM models for years, believe it or not,
Mhm.
and have been deploying, MCP things like MCP. They've been deploying their own kind of precursors to MCP and are now migrating over to MCP as it emerges as a standard. So the part that's
Mhm.
interesting for us is the traffic, because what we're starting to see is that increasingly the amount of traffic in the clusters in these production environments, an increasingly large proportion is coming from AI. And that
Okay.
becomes suddenly very, very interesting. Now, it's not 100% or 50%, right now. It's small, but it's growing because
Mhm.
people are doing more and more stuff. They're forced. They're forced to. If they don't do it, then their competitors are gonna do it
Right.
and
Right.
beat them. Um, and so that's where things get interesting for us. The feature that we announced a month ago at KubeCon was MCP support for Linkerd.
Mhm.
And what that means is that, Linkerd already sees all your HTTP and gRPC traffic, and we can parse that out and we can tell you, oh, here's a call to this, and we know all the details of that. Now with MCP, it gets a little more complicated because it's running on top of HTTP and it's a JSON RPC protocol, and you've got like, some stuff that goes back and forth. But now we can parse that and we can start emitting metrics and distributed tracing. We can start doing authorization policy at the level of individual MCP tool calls and and prompts and resources. So what we found is that for the majority of our customers, they have this traffic, like MCP traffic, they have this AI traffic in their environment, but they actually have very little visibility to what it is, which is
Hmm.
terrifying.
Hmm.
Is there a lot of it? Is there a little bit of it? I don't know. From the outside, it just looks like HTTP traffic. So the moment that you drop in Linkerd, we can now start parsing it out and we can say, oh, look, we found these 6 MCP servers in your environment. Did you know about that? Here's how much traffic they're taking. Here's the tool calls. Here's the distributed tracing that shows you, the agent was over here, and then it called the server over here, which called this thing in turn, and it waited 3 seconds. We can paint you this complete picture, and we fit it right into your existing telemetry stack. So I'm really excited about
Hmm.
this because, like I said, the problems that our customers are facing, the exact same set of problems that they were facing with like API traffic and microservices traffic, just translated to the world of AI.
Hmm. Wow, sounds a lot like really deep observability and telemetry for these AI workloads and the traffic patterns they see. I was wondering if you could also tell us about just an example of how and what this means for these teams who are actually using MCP and running AI workloads, and if they to use this feature of Linkerd, practically for them, how would it change their day-to-day troubleshooting or their tasks?
Yeah, yeah. So it depends on the specific usage. The majority of MCP usage today is like developers using MCP to have their kind of coding agent, Claude Code or whatever it is, connect
Mhm.
to some third-party MCP server. So that where Linkerd actually doesn't get involved at all, right? It's like
Okay, okay,
I'm running Claude Code on my laptop and it's talking to
okay.
GitHub over here, so we're not
Yeah,
going through the production environment at all. So that's level
okay.
one. Now,
Hmm.
the second thing that we're seeing, which is growing, but is early, is oh, we want to offer an MCP API to our customers. So we're actually going to run MCP servers in production. We're going to make them internet facing, and
Hmm.
our customers are going to be able to access our service over MCP. If that's happening in Kubernetes, then Linkerd becomes very interesting because once you
Hmm.
mesh those MCP servers, suddenly you have access to the full set of visibility. You can set up alerts, you can set up monitoring, you can set up, whatever you want, right? And you can see things like, oh, this tool call is the thing that's taking the longest amount of time and it's just getting hammered by this client, and therefore we need to do X, Y, and Z. Right now, you don't have that visibility at all. So
Hmm.
that part becomes really interesting for ops teams. And then the third thing, which we're starting to see inklings of in our most sophisticated customers, is we actually want to run an agentic workload in the cluster. And that agent is going to do stuff. It's going to do business process stuff. Right. And now, like, that's kind of terrifying from the
Hmm.
outside, unless you have really, really strong observability and really, really
Hmm.
strong security controls. But you can imagine
Right.
something running in there that's interacting with existing APIs in order to drive some business process. We have
Hmm.
customers
Hmm.
who are starting to do that. It's super interesting, but again, it's terrifying until they have great observability and the ability to really lock down and make sure that agent can't access stuff that is not allowed to. Right. And I think this is one of the most interesting aspects from kind of like the security perspective, because we've been talking about, as an industry, we've been talking about zero trust for like, I don't know, not a decade, but it feels like a decade, right?
Hmm.
But
Yeah.
it's always been kind of optional, right? Because we have all
Hmm.
these other protections in place. Oh, the code that we're writing, like an engineer wrote it, and we've got peer review and code review and stuff, and we deploy it in using blue green deploys or progressive deployment. But with these AI workloads, like, you have none of those guarantees. The only guarantee you have is like it's eventually going to try and do something that it shouldn't do. So you have to be zero trust. Like your whole environment, the moment you have one agent in there, your entire environment needs to be zero trust. Otherwise, that
Mhm.
agent is going to find the thing that like allows you to delete the database and it's going to call it, right?
Mhm.
So
Mhm.
just a terrifying but exciting new world.
Yeah,
And you
yeah,
don't
yeah.
get a choice. Like you have to live in this world. That's the part
Mhm.
that you know is really scary and exciting. You can't
Yeah.
ignore it.
Yeah, I wanted to talk a bit more about this idea of just zero trust and just how you uh, how you implement it and what it means in the service mesh. Because yeah, I mean, like when you think of like internet-facing MCP servers, sounds like risky stuff that can easily get compromised.
Yeah.
I came across a startup recently that just focuses on doing just that, just securing MCP servers, and so
Mhm.
that was the
Mhm.
first for me to see in that space.
Yeah.
That just MCP security alone is, yeah, the startups doing just that. Uh, Talk to us a bit more in detail about just this idea of zero trust for MCP servers, what they mean in the service mesh, and just in Kubernetes and in AI workloads.
Yeah, so I actually don't think AI changes a lot here other than it amplifies the need,
Mm-hmm.
right? So MCP servers like there's all sorts of interesting new threat models that they introduce into the environment, or LLMs in general, right? Like we've got new ways of
Mm-hmm.
breaking things. We're making
Right.
things insecure. We've got prompt injection attacks, and now like if you have an agentic workload and like either prompt is poisoned, like you don't know, but but that's all just a more extreme version of the original problem statement for all of the zero trust stuff, which is by default, you should not trust these workloads, right? And
Mm-hmm.
now, you kind of you would say that, but you kind of like would trust it anyways. Now
Mm-hmm.
you really can't trust it at all. So
Mm-hmm.
the zero trust kind of primitives that something like Linkerd puts in place are not on the MCP servers themselves. They're
Mm-hmm.
on the resources that those MCP servers need to access, right? And
Mm-hmm.
that's the layer that's the layer that's like the scary layer there is when you have this translation from like the world of AI where you've got all these prompts and whatever, and suddenly that thing needs to access an API. And that
Mm-hmm.
API is actually, it talks to the database, right? That's a layer where you need to put those protections in place. And you need to make sure that A, you know who the client is, B, you know what they're allowed to do, and C, you can enforce that they are allowed to call this endpoint, but they're not allowed to call that endpoint. So it's the exact same
Mm-hmm.
thing that we've been talking about the whole time with zero trust. You have to, like access needs to be denied by default. You need to have these really fine-grained, granular decision making, micro-segmentation, all that stuff. It's just AI has amplified that. It's turned it all up to 11.
Mm-hmm. Mm-hmm. And so you're saying this kind of access control and authorization, it's built into this new MCP feature that you launched, or do you integrate with an authorization tool separately and that handles the authorization and you give that tool visibility? Like what does this feature do? Does it just give you visibility or does it even
Yeah.
allow you to control access?
So the Linkerd model is we rely on the Kubernetes service account for identity, right? And that
Mm-hmm.
identity gets turned into your mutual TLS certificate, like the identity in your TLS certificate. And when we get a connection to a protected resource, like an internal service that can talk to the database and maybe can delete users as well as add users, that service needs to know who is talking to me and what are they allowed to do. And so those mechanics, none of that has really changed.
Mm-hmm.
The
Mm-hmm.
only thing we've done that is MCP specific is we've extended that model. So, we already allow you to set up access control based on individual gRPC methods or individual HTTP routes, right? So you can set up access control and you can say, hey, this client is allowed to call /add user, but it's not allowed to call /delete user, right? So you've already been able
Mm-hmm.
to do that. The thing that we've done is we've extended that model so that if you are meshing an MCP server, you can set up access rules on individual tools and resources and props. So MCP basically exposes the set of things to you. Instead of exposing a bunch of HTTP like routes that you can call, it exposes a set of things called tools and a set of things called resources and a set of things called prompts. And so now we've extended it so you can say, hey, this agent is allowed to call this tool, but it's not allowed to call this other tool. It's allowed to call this resource, but not this other one. So we've made it MCP specific. It's still, that gives you the power to be granular. What it doesn't solve is like you as a security aware person still need to set those rules in place and say, hey, access is denied by default, except I'm going to allow this and I'm going to allow that and I'm going to allow that.
Right, all right. Last question around this is just in terms of performance, and you mentioned about how AI is slow and Linkerd, you always
Yeah.
try to build things fast to move to perform fast. And how do you reconcile this? Were there any design decisions you had to make along the way while building this feature, and anything that you're learning about even just AI and how it works and why there's this latency and how you could improve things if you're running AI workloads. Any thoughts on just performance and latency, which is a big issue in AI?
Yeah, so for Linkerd, when we're able to deliver latency improvements and things like that, it's usually at scale. It's usually because, oh, you've got 10,000
Okay.
requests and we're going to load balance them in this really sophisticated way, and we're going to look at the latency of each endpoint. With AI requests, and by that I mean, traffic where there's an LLM somewhere in there and the LLM like takes a couple seconds to respond. That scale just isn't there. So everything
Mm-hmm,
becomes much easier from Linkerde's perspective. We're like, oh, you've got one
mm-hmm,
request every 3 seconds. We're used
mm-hmm,
to having like, a trillion requests in 3 seconds. So this is much easier for us to handle. And a lot of the things that we had to worry about in HTTP land, we don't have to worry about as much because of the pace is so much slower. Gosh, we've built this like incredibly fast vehicle where even a request comes in and we proxy it through and like we do it in a way that is called zero copy, where we're like we keep the data in memory and we don't like make copies of it just to start. Like all of this engineering has gone into this incredibly efficient system, and now it's like it's being fed one request every couple seconds. It's really silly. So no, if anything, it's made things easier because the bar is so much lower.
mm-hmm, mm-hmm. Wow. Yeah, really interesting. Sounds like, you really made like a Formula One car and now driving it on the roads kinds.
Right.
But, it seems like you're already kind of ahead of the curve when it comes to like AI workloads from what you're saying, and just Linkerd is ready for the AI era, and that it's not too different. It just looks different on the outside, but actually underneath it's the same. In fact, it's even easier, is what I hear you saying. But as you look ahead over the next year or two, what are you anticipating? What are you interested in? And where do you see this intersection of service mesh and open source and AI and all of these converging? What do you read up on, and what fascinates you today?
Yeah, yeah. I mean, what is interesting at the meta level is just how rapidly this ecosystem is evolving. And, we've done all this work to add MCP support to Linkerd, but what I've told the team is like, hey, MCP could, in 6 months from now, that might be totally gone, right? We might all be using some other thing. So like, let's move fast. Let's produce high quality software, but let's not imagine that the future has been kind of like is very predictable from where we are now.
Mm,
So the number one thing that we have to do, I think, from kind of the Linkerd project perspective is we have to stick really closely to what our customers are doing. We have to make sure that we're in this iteration loop where we can learn from them, and we have to be open to changing the product to do stuff, you know, as we all learn, as we kind of like collectively learn what the actual
hmm.
problems are. So we just can't
Right.
have this mindset going into it where it's like, oh, okay, well, we add MCP support. That's just like adding gRPC support. Like it's different. It's totally different. We have to set ourselves up to have this kind of beginner's mindset where we're not afraid to question
Mm,
stuff and we're really paying attention to what our customers are doing. I don't, my only prediction is that Uh, I don't think anyone can really predict what's going to happen.
Hmm.
Except I do want us to set ourselves up for a world where the majority of traffic in the data center or in the production environment, the majority of the traffic is AI traffic. Because I think that's the
Hmm.
way that the future is pointing. And so if that's the model you have in your head, the existing traffic is going to be eclipsed. You're going to have like 10x as much, and it's all going to be generated by AI. Well, how would you
Right.
design Linkerd today? Okay, there's a couple of things we would change, and so that's kind of like the that now becomes a roadmap for us.
Hmm. Hmm. Fascinating. Yeah, kind of echoes what we started with, which is just how do you keep your eye on the ball and how do you build for today? And, just be really pragmatic about it. And I think in that sense, you and Buoyant are really shining examples today of just how you can build stuff in open source, be profitable, and just make a big impact because there's so many organizations using Linkerd and so many paying customers that you have. And so it's quite fascinating just talking with you, just getting those insights and seeing all that you're building. Thanks so much for joining us today and sharing all of that with us. It was really a fascinating chat.
Yeah, thanks for having me. I had a great conversation, Twain.
All right. We hope all of our listeners and viewers enjoyed that as much as I did having this conversation with William. I want to encourage you guys go and follow him on LinkedIn, not LinkedIn, LinkedIn. Follow him on LinkedIn. He puts out a lot of really interesting thoughts on just the industry, open source, technology, different things. Really interesting person to follow. So go check him out. Go check out Buoyant and what they're building and the stuff that we spoke about today. Hazel, which is about just optimizing your AWS bill and the traffic across AWS availability zones. And we spoke a lot about MCP, which is also another new feature that Linkerd just recently announced. Go check out what that is about, especially if you're building for AI. And tune in again for the next episode, and we'll see you on that one. Take care. Bye bye.